let's get into the actual nuts and bolts of HTTP and HTML. So it was born in the late 1980s out of CERN. Tim Berners-Lee, his boss said, vague but interesting to Tim's proposal. Yes, that's true. And the web, it was at CERN, but it wasn't open source until the early 90s. I can't remember the exact date, but it was like 91, 92, 93, probably 92, 93. I set up my first website in 93, and it's a pretty early one. I worked for that research lab, and their big debate was, what is a website? What is this thing? Do we need one of these things? I'm like, sure. I'll set one up. And it married two things. It married a transfer protocol, HTTP, the Hypertext Transfer Protocol, with a markup language called HTML. What it did was not revolutionary in the building blocks. We've had markup languages since the 60s, if not earlier, SGML, which is way more powerful than HTML, by the way. We've had transfer protocols, like FTP dates to 1971, by the way, not a typo, it's 8 years older than IP, right? The first RFC for both FTP and Telnet was 1971. Yes, I read old RFCs because I'm a party animal, that's how I like to party, you know? And RFC stands for Request for Comments, by the way. A way into the standards are discussed and then published. So we've had transfer protocols since the 70s, if not earlier. We've had markup languages since the 60s, if not earlier. He just joined two very simple versions of those things together, and man, was it explosive, right? Set the Wayback Machine in 1989. 1989 is a terrible time for a protocol to be born. 1999 would have had a better shot at having some security, no security whatsoever. It was designed to effectively be an FTP server that supported hyperlinks, an anonymous FTP server, meaning. So there was no authentication, no sessions, no encryption, nothing, right? No security whatsoever. It was designed for public data exclusively only. And since it was public data like downloading, software or RFCs or something, there was no need to track sessions because there was nothing sensitive there. There was no encryption, there was no authentication, dead simple. And back in '89, all plain text. So if you sniffed it, it was all there, right? And this was common in '89. We would telnet across the internet in '89. I certainly did in '91 when I got involved with the internet. You type your username and password over telnet. Terminal emulation over network, by the way, is what telnet stands for. It gives you a terminal, a session. Your username and password, plain text. FTP, plain text. TFTP, plain text. Our commands use no encryption, right? There was virtually very little encryption being used on the net unless you worked for like a military contractor or something like that, right? And we had Kerberos, and that was about it, right? As far as encryption goes, right? But you didn't commonly do Kerberos over the internet either. That was usually an internal thing, right? Web v1, it didn't even have an RFC. The document describing it is about a page and a half, and I've read it. It's a joke. You couldn't possibly build the protocol reading that document. There's not enough meat on the bone there, right? All data was public, no authentication, no encryption, sessionless. Each individual method with its own TCP connection, which is super wasteful. Each individual GET, in that case, was only GET. The first version was only GET, by the way. That changed. Every single GET was a separate TCP connection. So SYN, SYNAC, ACK. The problem with TCP, and this is why Google came up with QUIC, we'll talk about QUIC in a bit. TCP, for every connection that ends normally, you're wasting 6 packets of not sending any data. The three-way handshake sends no data, SYN, SYNAC, ACK. If you shut down Grace, it's FIN, FINAC, ACK down, finish for FIN. SYN is synchronize, ACK is acknowledge. So 3 packets to set up a connection and 3 packets to end a connection normally with no data in them. That's 6 packets just wasted on every time you connect to anything, right? So if you go to a modern web page, like you go to nytimes.com or something, or ESPN or whatever, I go to nytimes.com, and this is with an ad blocker, so I'm actually seeing less than I normally would, but that's a GET, that's a GET, that's a GET, that's a GET, that's a GET. Every single image is a GET. That's a GET, that's a GET, that's a GET. These are all individual GETs. This page has dozens of images, dozens, right? Probably 50 when it's all said and done. So 50 connections, 50 TCP connections originally, that's changed a bit now. And each of those connections throws 6 packets away with no data in them. No actual application data, right? Very wasteful. And this is the first website. They actually kept a copy of the first website in a modern browser, of course. And a more time-appropriate view of that, I believe, is in the notes of what it would look like in a curses-based interface. Browsers didn't look like this back then. They used curses, which is terminal characters, right? 0.9 is the retroactively named original HTTP. We just call it HTTP. We renamed it 0.9. HTTP could only transfer HTML, that's it back then. No images, right? It's a very, primitive time. There was no virtual host support, meaning one IP, one website, that's it. All websites were Unix back then, which is why the URL format uses the Unix style slashes, not the Microsoft style slashes, because every web server was a Unix server back then. That's changed, of course, since now. That's why URLs followed the Unix slash format, right? Directory style format, right? Again, it could only transfer HTML, but today, most modern browsers still support this out of the gate. I've bypassed WASP by downgrading my connection to 0.9, and I sailed right through. So one of the things I mentioned earlier is I like to do crystal box testing, full knowledge testing. One of the things I always ask for is last year's pen test report. Give me a copy of last year's pen test report. That's a very useful thing to get my hands on. And also, as a value add to my client, I tell them how valuable I think that pen test report was. And I often ask, how much do you pay for this report? And I saw one pen test report that was someone ran a Nessus scan, put a cover page on it, and handed it in as a pen test report, a Nessus scan. And they charged $25,000 for that scan. Like, man, you got robbed. And it's not always that bad, but it's pretty bad often, right? So I'll give a little value add on what I think, what value they derive from that report. And I've never seen anyone try that. Like, I read pen test reports to see what they tried. And then if I read last year's pen test report, and I see they really went whole hog in the server in a pretty thorough way. Not that I won't look at it, but I'm gonna, they probably would have found it. This thing they barely looked at, I want to dig more over there, that kind of a thing. I can kind of inform my pen test based on what they did, right? So downgrade attacks, I've never seen anyone try that other than me. I'm sure others have, but these are things, knowing the underpinnings of a protocol make you a better pen tester. Knowing this stuff. It's not just historical baggage we're covering for the sake of completion, right? It's useful stuff today, right? 1.0 began to look more like the web we use now. 1.1 is what most of us have used for most of our careers, probably, right? This is the first formal standard with an actual RFC 1945, where they famously misspelled referrer, by the way. One of the most famous misspellings in internet history is a misspelled referrer. Every referrer your browser sends is spelled wrong per English, by the way. Leads to all kinds of confusions. I've had tech editors try to correct my correct spelling of referrer, which is the incorrect way, which is this way. I spell it the way the RFC does, because that's what the RFC says, right? Get 3 R's refer, not the 4 R's that are supposed to be there, right? This is more modern. We've got gets and heads, safe methods that download stuff. Get downloads a page, head just pulled down a header, as the name implies, right? Post, put, delete are also there. Post, you send data to an existing application or script. Put, you're creating an application, or you're creating data, you're creating a file, rather. Delete, you're deleting a file. Now, you might think, on what crazy world would anyone turn on puts and deletes? You see this stuff more commonly now, like Microsoft's WebDAV. It's like basically a directory browsing experience in a browser, where you're clicking on folders in a browser. Many of these types of technologies use puts and deletes because you're copying files you can move files in a browser. So many of those types of technologies use put and delete at the back end. If I can upload a file, what if I upload a PHP file with a PHP backdoor to your PHP server, bang, I'm in. What if I delete the htaccess file to turn off your access control, right? You might think, Eric, you shouldn't have the permission to delete that file. I shouldn't, but I'm going to take that shot every time. So these are intensely dangerous. On a pen test, this includes on day 6, posts are very interesting. You want to explore every post deeply. I'm not saying it's always posts, it's not, but I see posts, I go right there. That's one of the first places I start, where you're sending data to an application, right? And we'll do plenty of that this week. Big change with HTTP 2. This builds on our earlier talk of an ever-encrypted internet. Our sniffers aren't seeing plain text data anymore, right? So what happened was, the web has been a series of ad hoc changes with very little standardization. Some things are standardized. RFC 1945 describes HTTP 1.1. That's a standard, right? Many things weren't standardized. People were sick and tired of HTTP 1.1. They wanted something better. The standards body was slowly working on HTTP 2, slowly. Google got tired of waiting, so they pushed out SPDY, SPDY. SPDY is mostly this, but not entirely this. That was their take on HTTP 2 because they were tired of waiting for the 10 years to go by for the standards body to finalize this thing. So they pushed out SPDY. And Google controls a lot of browsers and a lot of websites. And then Firefox said, yeah, Speedy, I like that. Let's do that too. So Firefox implemented Speedy. It's not a standard. There's no RFC. They just pushed it out there. And then HTTP2 was coming out, which was mostly Speedy, but not exactly. They're like, well, we'll use these parts of Speedy, but not that part of Speedy. One thing Speedy did, SPDY, it requires encryption, right? Speedy requires encryption, SSL, TLS, whatever. This does not. And that was a political discussion. So Google said, well, of course you're going to turn on TLS. You're going to come all this way for a new protocol. Of course it's going to be encrypted. The standards body said, no, we're not going to require encryption because at that time, an X509 cert cost money, right? You couldn't get, you can now, let's encrypt, right? But before then, you couldn't get a X509 cert that was trusted by some company like VeriSign or GoDaddy or whoever without paying cash. There were some free ones you could download as a private person for your own personal use, but for a business website, you had to pay. The standards body felt it was wrong to force users to pay to use a standard. So they said HTTP2 does not require SSL TLS. We'll talk about SSL TLS in a bit, hold that thought. And the reality is most websites do. Speedy still does. Most websites force SSL through this, or TLS, but it's not actually required. And it's multiplex, not pipeline, meaning if image 17 dies, the rest are unimpacted. Binary headers and binary data. So days of running Wireshark and eyeballing stuff, that's going away too. Not just for the encryption, but also for the compression, right? This is interesting here. Push promise, there's a black hat talk right there. I can send data to a client that the client did not request. What? I can send unrequested data to a client, push promise. Here you go, right? What could possibly go wrong, right? What could possibly go wrong, right? There was a black hat talk right there. I had time to research it. I'm telling you, there's something there. Pushing unrequested data, what could possibly go wrong, right? So it's effectively always encrypted. I know there's an asterisk here, it doesn't have to be, but I've not seen this unencrypted in a while, put it that way. And the headers are binary, so it's getting harder and harder to analyze this stuff. It's getting harder and harder to proxy this stuff, right? We're becoming more and more blinded on the wire. Then quick. So Google's like, we're sick and tired of waiting well, we finally got HTTP2, but it's still got all the problems that TCP has of 6 wasted packets on every connection, 20-byte header versus an 8-byte header for UDP. We can't rebuild everyone's stack on the internet. That's billions of computers. It'll never happen. So we'll just do our own thing. We'll run essentially TLS, HTTP2 over UDP port 443. That's quick, QUIC. One thing I've learned, there's a famous quote by Donald Rumsfeld, and I quote it all the time. Donald Rumsfeld said, there are known knowns, there are known unknowns, and there are unknown unknowns. And the last ones are the words. Like, wow, my brain is just killing me right now. What is this? Okay, known in this world. We can inspect port 80 traffic, HTTP. We know it's there, and we can see it. Known unknown. We've got TLS traffic that's not being inspected right now. We know we're not inspecting it. We know it's there. We're considering buying a blue code or something to intercept that stuff, do SSL intercepting, but right now we're not. But we know we're not seeing that. Unknown, unknown. Most of my clients didn't even know they were using Quick while they were using Quick, right? So most of my clients were using Quick without knowing they were using Quick. That is an unknown unknown. And the things, those are the ones that burn you the worst. One of my clients, and they have Blue Coats. Blue Coats, one of the technologies that can do SSL proxying. And the way, there's 2 ways to intercept or to proxy SSL, normally these certificates would get in the way, right? The certificates, you're going to PayPal, but you're really going to a proxy. The proxy goes to PayPal. Normally, your browser's going to freak out. It's seeing the proxy cert, not PayPal cert. So what you do with a tool like Blue Coat for active interception, this is active interception now in proxying, you basically take the cert from the proxy, you import it into the certificate store of every browser, laptop, desktop you have to trust the entire internet. Now, you don't get any warning because it's trusting that cert for the entire internet, but you have to touch every client, right? That's SSL decryption and proxying, right? So my clients were doing that. Their biggest concern was webmail, and if you surf to Google, Gmail, you use Quick. From Chrome, you're using Quick, right? So their biggest concern was webmail. They're intercepting SSL TLS for webmail, but every Chrome user, which they all use Chrome, who went to Gmail, it went straight out the front door uninspected. They had no idea it was even happening. Now the solution to that is easy. Block UDP port 443, block UDP port 80. then your browser's will then fall back to TLS 1.2 probably. But you need to know that's there. There are no tools to intercept this. Anyone know of a tool to intercept Quick? I'm not aware of any of them, right? So Burp and Zap can't do it. So it's a huge, huge blind spot, right? Huge blind spot. At minimum, you have to know it's there. And you want to make sure, if you're concerned about inspecting SSL TLS traffic, you should not be allowing Quick out, because it's not being inspected, okay?